So we're going to deep dive into the three main concepts here. The first one is how do you create and log these agents and what are the new tools we have on that space. The next thing is how you can deploy them and then how you can trace them so that you can go inside the application and debug faster. So let's see one by one. The first thing here is to understand the difference between chains and agents. Chains, as we were doing with LangChain, for example, is, again, it can be a set of things happening in an application, but a lot of the things are hard-coded inside. They are not modularized, they cannot be configurable, so again, you kind of have a hard-coded monolithic application in that sense.
Okay, you have to recreate it every time
Exactly.
that you want to change something. Okay.
Where an agent is a much more advanced system that may have many different concepts inside and
More flexibility.
And sometimes it even allows the large language model to make decisions on where it should go next. That is the main difference here. And the agent framework mainly is a framework that helps us code these agents in a much more flexible way. So let's see what this means mainly. In general, when we start coding for, here we're going to use RAG as a basic agent system because, as we said, it has a lot of different components and we can really modularize and tweak them. So we'll take RAG as a simple agent in this case. And there are different ways that you can mainly query these kind of applications. And we kind of recommend the OpenAI chat completion schema because it's consistent and it's a lot much more flexible than if you go and code the things yourself.
So it shows that we really interpretable.
Bravo. And you can have a common schema across all your applications, to be honest, as well. So you have your message, you pass the role. As we said, this is the user, this is the question, the assistant takes the content and any content from the vector store, and then you give the question to the system. So mainly we're going to work with this kind of framework for now on, but here there are documented different things for it, especially if you want to do multi-turn chat applications, right? So there are different kind of ways to configure the input to your chain mainly. Now, this is the input schema. The output schema of a RAG agent, again, it can be a chat completion response and using the OpenAI format as well, which can look like this. So one thing to turn your chains to a more configurable system is instead of hard coding all the parameters and arguments that go into the chain, you can pass them as configurations.
Okay.
Mainly, that is the main thing that you have to think, right? That instead of hard coding your parameters into your chain, you are gonna create a configuration file. It can be in any format, a JSON, a YAML, that you go and document all the parameters that will go into your application and apply the different values to it, right?
Which is what gives you the flexibility that we were just talking about.
Because this now configuration sits outside of your system and you can pass different configurations and different files, and which will result in a different compound system, in a different agent application at the end of the day. And then you can compare configuration A versus configuration B. And here, this means that you can configure anything around the LLM parameters, which is the actual LLM you are using into your application. What is the prompt? So you can do tweaking of prompts very easily. And anything else that mainly goes into your application and you would find yourself hard coding, you can now pass it as a configuration file. So you can do it as a YAML, you can do it as a dictionary, and then mainly you use the MLflow and the model config to pass this into your application. And then you can access it. In order to log the agent, think of the agent as, I would say, think of it as a model because we're going to log it with the same way as we log any models in MLflow, right? So in order to log any model with MLflow, what you have to do is hit MLflow with a specific flavor of the model. In our case, most of the chains or agents we are building are built with LangChain. So that's why we're going to use the LangChain flavor of MLflow. And then you're going to log the model. Now, it's very interesting here to make sure you set where this code that will create your model is. And this is done with models, MLflow.models.setModel, and here you pass the notebook or the path to the file where your code for the chain is set.
Yeah.
Okay. So in a notebook, you created your chain. In another notebook, you actually go and declare that I want to log this chain, and you can find the code for this chain into this specific file. Okay, which is sitting here with LangChain. So this is what it is recommended from Databricks perspective, the code-based logging. So in one space, you declare the code for the chain, and in the other space, in the other notebook, you are actually declaring that I want to log this model, and I want you to go and find the path to the code in this specific location. Now, you can do this with a LangChain flavor, or you can do this with the pyfunc flavor in case you want to have some more flexibility, as we know, because the LangChain flavor is already pre-implemented for you, and it has wrapped a couple of things already. But if you want to build your own flavor and you want to have much more flexibility, you can do exactly the same with pyfunc. And let's see an example of how this is done. So this is the code path. So this is where I have stored the code for my chain. I'm declaring my LangChain chain and all the different steps inside.
Okay.
And this is my configuration file. So
that we just talked.
Right?
Yeah.
And it's a configuration file that outside of my code, I declared all the parameters for my chain.
So it's fully modularized. Yeah, makes sense.
Nice. So this is an input example to just give to the app an example so that they know what they should look out for or wait for, right? So this is what they should expect to see from the user as an input, for example. And then you start the MLflow run. From here on, we start the MLflow tracking. And we said we are going to log the chain with LangChain in this case. And we're going to log this model with MLflow. And we're saying that the code for this model or chain is in the specific code path that we passed above. So it knows that in order to compute this chain, they have to go and execute this file. And I'm passing all the model configurations, and this is the configurations for the chain that we're passing in this specific YAML. I'm saying this is artifact chain, this is for MLflow. I'm passing the input example as an example to expect. And this is a required argument for this implementation. You can do the same for the pyfunc. You can see that nothing really changes but the fact that I'm using the Python log model, and I'm using not the LC model, but the Python model and I'm passing again where the notebook is, and nothing else really changes. And with that, I can log my model to MLflow. And then, as usual, if my model is logged with MLflow, I can then load it from the specific URI and invoke it and hit it to get the response. And that you can do to verify, that you can do in the same notebook to verify that it's actually working as expected. Now, how can we log this chain to the Unity catalog? Mainly, we are saying that we're going to use the UC registry. We define catalog schema model, and we register the model. Nothing changes. As I said, think of your agent or compound system as an MLflow system, as an MLflow model.
Yeah.
And that's it on how to log the agent. And then you can deploy the model, and then you can invoke the chain. And this is called the code-based logging. So far we have logged the model with MLflow, logged the agent with MLflow and Unity Catalog, and now we want to deploy this agent. Again here, nothing really changes but the fact that we have some extra features available for you. What you can do now is deploy your agent straight to model serving.
Yeah,
as a model.
Awesome. Yeah,
right?
This is really good.
Straight to model serving, you pass your model and you allow the model serving to create the Docker container and serve it for you. And then you have this API at the end of the day that you can just hit from other services. Or another option to deploy this agent is with the deploy function. Now, what does this do? It's interesting. The first thing is that it actually kicks off a similar CPU model serving endpoint to serve your agent as an API, as we said before, but also it kicks off this review app for your agent. This is amazing because now you can send this application to anyone outside of Databricks, right, to anyone in your company.
Non-technical users.
To non-technical users.
Subject matter experts that actually can review the quality of your output.
Exactly. So you send this application to your stakeholders, and they can send some questions to the application and review all the answers. They can say good, bad answer. And now all the data are logged into Delta tables so that then you can access them, see them, and use them as an evaluation data set.
So you'd recommend to use deploy in dev before using model serving.
Before just throw it into the model serving, just make sure you validate it with your stakeholders. And that was built so that we can iterate and collect feedback faster. And again, everything is logged with MLflow, and all the requests are logged on Delta tables as well. So this is excellent. How does it look like? You just need to import from Databricks agents, import the deploy, and then you say deploy, pass your agent, and pass mainly your chain. And here you pass the model version from this chain. And that's it. Now, the other thing is that there are a couple of different tables logged when you use this deploy function with MLflow. And one is the payload, which is all the JSON payloads that come to the endpoint. The request logs, which tracks everything that tracks above, plus the MLflow traces. So what's happening on each step of your chain so that you can go and debug. And the assessment logs, which is all the review feedback you got from this application you released.
This is awesome because I guess this also allows you to just build some training data.
Exactly. Right? Now you have your evaluation data set, or then you can use it for fine-tuning models. Now, last thing, let's see how you can kick off this tracing. This is in public preview, in public preview, and we have these Fluent APIs now in MLflow 2.13 and plus one, 2.13.1. Yeah. And let's see how you can start the tracing process. So you can create your chain, and this, as you can see, is a pyfunc model. So we are doing an extra. Actually, this tracing is very flexible, so you can add it in your pyfunc models in any class you are building, so you can tweak it and add any tracing you want, to be honest. And you use this MLflow decorator to allow the tracing to be seen in specific naming convention, right? So you say here, I'm kickstarting the agent. So when you go into the tracing UI, you will see this as a name of a step. So that it's easier for you to debug. And here mainly you are predicting, you take the model input, the system prompt, and then you creating the message, and then you are predicting, you are saying model trace predict, and here is your predict function mainly, right? So you pass all the parameters and you get the output of the model. And that's it mainly. And you can declare as many of these things as you want and as deep in steps as you go on. So in every function that you're hitting, you can declare a different step that is happening for the tracing to kick.
It's really interesting because before, when something went wrong, there was no way to really trace.
To know what's happening inside. Yeah. So, and then when you perform inference, really you don't have to do anything. It's just you're passing, you're instantiating your chain, and you are kicking off the predict function with your query and your system prompt. And then when you hit that, you're gonna see as a result your tracing UI that inside you can see what steps did the agent go through to create the output you wanted. And for each step, you can see the input and output created. Last thing is, after you have deployed your agent and you have done some manual evaluation with your stakeholders, you have collected some feedback, then what you actually need to do is start thinking really about your evaluation data set and how you are establishing some ground truth so that you have kind of a more automatic also way to capture these metrics. So think of your application first of all and try to understand what are the KPIs for your application, because different applications have different metrics that you have to track, but mainly they come into three different things. The response metrics, so how accurate, consistent is the response. Yeah. The retrieval metrics, so this is mainly for RAG, to be honest, so where the return chunks relevant to what was the question.
Yeah.
And then the performance metrics, so how many tokens were used, and how latent, like what was the latency of my application. If I have a very low latency requirement, then I have to make sure my application is very lightweight and so that I hit my KPIs. So after you have defined your metrics, then you can kick off some evaluation runs. So through the agent framework, now we have a way to run our application as part of an evaluation run, which compares its result against mainly our evaluation set. Now you can do that also and combine it with human feedback that you can collect from the review app, or you can use LLM as a judge.
Yeah.
So this means that I am passing the question to my application, I'm tracking the response of my application, and then I'm using another LLM, which is considered to be better than mine.
Yeah, generally we want to use it.
To say, was this question, is this accurate, right? Given this question, given this response, how good is the response?
Yeah.
And I'm tracking all of this, and I'm using this as an evaluation.
And you can also give indications on how to evaluate how good the response is.
Yes.
Based on your own way of evaluating.
Exactly. So you can even create bespoke KPIs and ask the LLM as a judge, I want to evaluate it based on the specific business requirements that I have, for example.
Exactly. So for example, you want to summarize news events and you want to give it a score from 1 to 5, depending on, the element of this event that it got right. So for example, did it get the stakeholders right? Did you get the location right, the date right? And maybe it's a 10 out of 10. Whereas if you got everything wrong, you want to give it a 0 out of 10.
Exactly.
And the great thing about using a really, really large LLM is that it's able to see all those nuances and evaluate that for you.
Also, the good thing is that this happens behind the scenes as a batch job. So it's fine if it's a big and it can add a little bit of latency. We don't really care, right? It's happening behind the scenes. It's not real time. We can do it once every week or depending the frequency we care about. Let's deep dive a little bit into the evaluation and how it is done with MLflow. So we have a new kind of API which is called MLflow.evaluate, where you need to pass the evaluation dataset. So you have collected some answers that are quality and you went through them and you validated them, that you can now test them against the answers your application or your agent is created. And you can do that in the same MLflow run that you are logging the model, and you can kick off the evaluation. Or you can do it outside, and you can, by default, it's going to create a new experiment for you. And that's it. And by executing this command, mainly it computes a lot of metrics around the quality, the latency of your application, and all will come as one at the end of the day under the same MLflow experiment mainly. We're going to show you a demo on how you can use agents and all the different tools that were released from the summit. So let's see what we have here. So we have a RAG application that we have deployed, so nothing changes really here. The one thing that changes is that we want to make sure that our application is modularized. So how do we do that? We are going to define the config for our application. And here we have the chain config, explaining what is the serving endpoint, where is my endpoint for the model to use, which is my vector search endpoint, which index to use, what's my prompt template. In this case, you are an assistant and you are answering questions on Databricks documentation. And if you don't know the context or the question, don't answer. And this is an input example that the application or the chain should wait for. Now, the next step is how we can log this agent application and how we can view the trace. Let's see how we can do that. It's actually very easy. As we said, we will think of our agents as machine learning models, as MLflow models, and we log them in similar way. So in our case, we're going to kicking off the run, and we're going to use the LangChain flavor to log our chain. Now, the model code, in our case, sits into this specific path and actually sits in this specific repo in this case. So you can even link it to a repo to go and find and fetch the code for you. You're passing the model config, which is the config that we declared above. And we're passing now the input example that we showed above, like what is an input example that the application should expect. And you can just log the model by that. Now, in order to test and see that it's working and kick off the tracing, you can do LangChain log model and you invoke the chain. And let's see what we can see here. This is the tracing that we are going to have as an output. And think of this as different steps of your application. This is your input layer that mainly retrieves the question, right? That is the only thing it knows at this point. And then if we start going into the different steps,
you can see what happens.
Yes, we can see exactly what happens at each step. So here we have the question from the user. So what is the retrieval generation? As we go into these steps, you can even go into more stuff that's going, like how...
You can see how long it took as well.
Exactly. How long each step of like all the different functions that are being called behind the scenes, you can go and see them. All the different invocations that are happening by LangChain that we don't even know are logged here. And then this is the pass through that passes the question mainly to the chat application. And here you can see that actually generated the passage. So here it invoked the vector store. So this is the question and this is the output, which is the output from the vector search.
Sorry, what do you mean by passage?
Passage is just the context that retrieved from the vector search.
Okay.
Right? The passage we call it, no? As in a passage of text, no?
Okay.
Something like that, I believe.
Okay, makes sense.
Ignore it. It could be context or something. Yeah. So here is your vector store retriever, all the metadata, the chunk ID for each specific passage that...
page content.
That's retrieved. And then here is the passage as an input now, right? Yeah. And the question. And here we're passing any additional arguments that we may have in the application. In any case, we don't have much. And then we are hitting at this point the chat. So here at this point, we're kicking the endpoint that we have the DBRX model.
Yeah, that takes everything
graph.
And then out.
Let's see, we're passing the endpoint. Here you can see the temperature, all the parameters, and also the content, which is the system prompt, as well as all the retrieval generated content, that blah, 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 blah. All of this is the context we got from the vector store, as well as an additional parameters that we are passing to our application. And as a result, you can see this is LLM output. And here at the end of the process, you can see like the output of all of this was actually the generated summary of this question.
Yeah.
Does it make sense?
You see the whole end-to-end process.
Exactly. So, and you can go as deep as you care, and you can go and declare as many traces as you want at this point. So in this way, you can test what is happening inside your application, something that you couldn't do before.
And it's good for debugging.
Exactly. The next thing is how we can deploy these agents. So first thing is we're declaring that we're going to use the Unity Catalog registry. Then we're registering our chain with MLflow. And then we are hitting the agents.deploy, as we said. That what it's going to do behind the scenes is kick off the model serving plus the review app. So let's see the review app, which is actually very cool. So this is the review app. You have the different instructions, you have the chats to review and to test the bot.
So just to clarify, that's outside of Databricks, right? Meaning people...
I mean, it's hosted by Databricks.
It's hosted by Databricks, but you can have non-technical users coming in here and doing the review.
Yes. So here we are, the review app that was automatically generated by kicking off the deploy agent part. And this app is hosted by Databricks, but it can be accessed by any stakeholder outside of Databricks. Yeah. So you can send it to anybody, to be honest.
So that you can review the quality of the output.
Exactly. So what you can do is you can come here to the chat and say, for example, what is Databricks? You send it, and now it's hitting the serving endpoint. It creates the answer, and then it waits for you to evaluate it. So is it good? Is it bad? Blah, blah, blah. Let's say yes. And then it even asks you about the different specific KPIs that you may be interested in. Is it relevant? Is it accurate? Is it safe? Is it helpful, right? And by doing that, you are actually sending the feedback back to our data tables and the logs. So with that, you can just crowdsource the evaluation of your application to all your stakeholders, collect some feedback, and then go and iterate.
It's really awesome because you can get, it's especially awesome that you can collect this data in a structured way and able to reuse it for all sorts of purposes.
Exactly. And the last thing is on the agent evaluation. So in order to evaluate your chain, we need to create, as we said first, an evaluation dataset. So this doesn't have to be a lot of points, but a couple of points that you have validated their quality and hit your KPIs of what a good application should look like.
Well, actually, if you use the app, at some point, you're going to have a good evaluation dataset, right?
So in this case, we have the request, like what is the question and what is the expected response. We have created a couple of examples here for the sake of the demo. And in order to kick off the evaluate, you actually say MLflow evaluate, pass your data frame, pass what is the chain we are evaluating, and you have to say that it's a Databricks agent. It's to activate the Mosaic evaluation. And what does this do? So it goes and evaluates your model against all the different metrics, like what is the precision, what is the rating, correctness, blah, 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 blah. And also go and logs all these different things against all the different responses that you have passed to be evaluated against.
All the metrics, is it something that's static or can you configure it or how does it work?
To add more metrics, you mean? Now, that's a good question. I think as of now it's static, but I'm not 100% sure. Probably you could add your own KPIs here as well. And there is also this evaluation tab that is created that you can see it in a more visual format. And for example, you can see the response, what was the response for the specific ID, what was the rating for safety, was it a safe or not safe response. And if you come to your run page, you can see all the summarized metrics about latency, and then you can even compare it against different models and different runs you did to see the difference in performance. And also you can go into the tracing tab and see all the different traces you did.
That's awesome.
By clicking the agent deploy, right? So all the different tracing attempts, and you can come here and see the actual tracing and see how things change from model to model or from iteration to iteration. And you get the request, the response, how long it took to be executed, and all the information in one page, which is really nice to have summarized. One more thing to know is we have this generative AI cookbook that you can go and have a look. We have all the best practices to guide you through how to build compound systems and agents.